Welcome back to another lesson. In the last one, you learned to make predictions using a linear model. In this video, we will look at a more standardized way of initializing a linear class. We will discuss the theory as we implement it into code. So on a new Python notebook, first you must import the relevant torch library, and from torch.nn, we will import the linear class from the nn module. You will first write the following line of code on a new cell. Torch.manual. We seem to have a problem, being that I have to rerun this cell. And so I'm just going to fast forward this video until I do. See you in a bit. All right, and we're back. We will start by finishing up this line of code. Torch.manual _ seed 1. What this does is it sets a seed for generating random numbers. The reason we're doing this is when constructing our model with the linear class, it will be given random values for the linear class, which makes sense since, recall, we start with a random value for the weight and bias, and then we train our model through a gradient descent algorithm to obtain the optimal parameters to fit our data. We'll talk about training shortly, but for clarity, and to see progress in training our network, we want to ensure that the random values assigned to our weight and bias values are consistent. Hence why we set a seed. The seed can be anything that you want it to be, so long as you don't change it. If you wish to obtain the same results that I get, then feel free to use the same seed. All right, let us now construct our linear model with model is equal to linear, and it will accept in features is equal to 1, out features is equal to 1. What this means is that for every prediction that we make using our linear model, for every output, there is a single input. By creating this object over here, we've created a linear model, and we can determine the parameters of this line by printing print model.bias as well as model.weight. We get our weight and we get our bias value. This would result in the equation y is equal to 0.5153x minus 0.4414. Perfect. Now, provided this model, we can now make a prediction based on an input x, which we will set equal to torch.tensor, and we will pass in an input of 2.0, noting that this is a float value, and we will call upon our model, and pass in x as an input. This should return a prediction which we can print out, print model x. It outputs a prediction of 0.5891. One can make several predictions by passing in several inputs. We can pass in an input equaling 3.3, and noting that our linear model only takes in a single argument, we must enclose this in a bracket. So what's going to happen is for each input, we will get one output, one prediction. And printing this out, the prediction for 2.0 is the same thing as earlier, and we also get a prediction for 3.3 to be 1.2590. This lesson was to get you familiar with the linear model class, which provides a more concise, easier, and more standardized way of constructing a linear model. We will be using this class all throughout this course. In the next video, we will explore custom modules, a robust and efficient way of building neural networks with PyTorch, and for the purposes of this section, we will use it to further configure our linear model. I will see you there.